Hi, AP Calculus. I was going really fast on that last video, and I think hopefully you caught my mistake, but it actually is going to serve well because it's like my teaching moment. Remember when I said if you show me good calculus and you make a simple error at the end, I might get like 8 out of 9 points for this. What's wrong with my last fraction? Well, 4 goes into 8 2 times and into 12 3 times, so my fraction was really negative 2/3. But if I had just plugged in and came up with negative 2/3 and gave that answer with no work, I would not get my points for it. All right, anyways, beating a dead horse. Here's another problem similar. They give us the limit as x approaches 4 is 0. The limit of g of x is 3, and we're going to analyze these limits. So this would be the limit as x approaches 4 of g of x over the limit as x approaches 4 of f of x minus the limit as x approaches 4 of 1. The limit of g of x this time is 3. Limit of f of x is 0 minus 1. So that's going to be negative 3. All right, this is going to be the limit as x approaches 4 of x times the limit as x approaches 4 of f of x. This is going to be 4 times the limit of f of x, which is 0, and 4 times 0 is 0. Why is this one 4? Just in case you forgot, we're just plugging in that 4 there for x. All right, number 11, the limit as x approaches 4 of g of x plus the limit as x approaches 4 of 3. The limit of g of x, they give us is 3, plus the limit of a constant is a constant, so this is 6. And this is the same thing as writing the limit as x approaches 4 of g of x squared. And the limit of g of x would be 3, so this is 3 squared, which is 9. All right, find the limit of each of the following exponential functions. So this is really what we were doing last night. You don't have to do a really fantastic sketch, but it always helps to make a sketch to kind of figure out what's going on. I know here's my asymptote up at 3. It should be a decaying exponential like this, but my horizontal reflection is going to turn it into a growth, right? So it's going to, a growth. But then the negative is going to actually make it turn and go down like that. So when we look at the graph as it goes to infinity, our limit is going to go off to negative infinity down here. For number 14, 2 is a whole number bigger than 1, so it should be, well, here's my asymptote, right? It should look like this, but this horizontal reflection is actually going to make it turn and go something like this. So as we go to infinity, it's going to go to my asymptote, which is at 3. And then finally, 15, we're also up here at 3. It's a fraction less than 1, so it should look like this. Horizontal reflection is going to make it a decay. And then a vertical reflection will take this graph and make it flip down across that asymptote. So as we go to negative infinity, we're coming up to that asymptote again, which is there at 3. All right, number 16. Got another whole number bigger than 1. Here's my asymptote at 3. It should be a growth. Again, horizontal reflection is going to make it a decay. Vertical reflection will take that graph and flip it down. So now, oh, just kidding. What's different about this problem? If we're not going to infinity, we're just worried about it negative 2. So we really don't care that that's what the graph looks like. We're just going to evaluate this guy. It's going to be negative times 3 to the minus, a minus 2, minus 2 plus 3. So this is negative 3. Minus a minus 2 would be positive 2. Minus 2 would be to the 0 power plus 3. Anything to the 0 power is 1, so this would be negative 1 plus 3, which is 2. For number 17, I've got 1/2 to the minus 2 plus 2 power minus 1. Again, to the 0 power, 1/2 to the 0 power is 1/2. Minus minus 1 would be negative 1/2. And then for number 18, I've got 2. The minus of minus 1 minus 2 plus 2. So that's 2 to the 1 minus 2 is minus 1 plus 2. That's 1/2 plus 2, which would be 5/2. Okay, 4/2 plus 1/2 is 5/2. Oh, okay, so I keep getting messed up. I'm looking at 17 going, that's not the answer I'm showing. What am I doing wrong? Let's go back to 17 real fast. You probably already figured it out. You probably rewound the video 5 times and been like, Miss Harris, you're wrong. I just know you're wrong. Anything to the 0 power, Miss Harris, is not itself, is 1. And then 1 minus 1 would be 0. Does that look better? Hopefully so. All right, use the graph of g of x pictured to the right to find each of the following. So the limit as x goes to infinity, yay, they graphed it for us. As we go to infinity, we're going to go to the asymptote, which is at negative 1. As we go to negative infinity, our graph goes off to positive infinity. As we get close to 1 from both sides, we're up there. It looks like we're right there on the x-axis, which is 0. And then as we go to negative 3, it looks like we're approaching 3 from both sides. All right, that is it for calculus notes. You have your quiz on Monday. Like I said, it's 7 multiple choice and then 1 4-part free response. You're not going to be perfect on this free response, but we're going to start practicing right now because that test is a-coming.